Hello everyone, welcome to my channel. Have you ever thought how does large language model know when to stop text generation process, or why does it large language models are like a chat GPT or Google Gemini just keep doing text generation for a long term sequences? Okay, so well, today we are diving into the something super cool large language model parameter, that is stop sequence. Stop sequence like a traffic lights for the AI content generation process. It controls the large language models where to stop the text generation process. In this video, I am going to discuss about define a stop sequence. How does the stop sequence works? What happened if the stop sequence never found by the large language models when it's text generation process? Recommendations of these stop sequences, best practice for the prompt engineering, and explore few special stop sequences which I have done research. By the end of this video, you will not only get it, but you will also feel free to use it like a professional. Additionally, today I will unlock the free certification on generative AI with the combination of LinkedIn and Microsoft. I will share the tips and tricks to achieve this certification with zero costs. Let's dive into the topic. Stop sequence. So stop sequence is like a setting to the large language model that instruct the model to stop text generation process once it encountered by the specified string, symbol, or a word. So stop sequence is not just a symbol. You can use that like a word or any symbols also. Okay, let's do some practice with the examples. Okay, so before diving into that, I will just give you brief about Google Cloud Platform, which is offering free credits for your best practices in doing the prompt engineering. This is the main dashboard. So you can access the large language model like a Google Gemini itself in the Google Cloud by setting on the Vertex AI. So this is, you just click on the Vertex AI platform. So once you click on that, you will be launched into the Vertex AI dashboard. This is the Vertex AI dashboard. You will find a lot of options. In the left side, under the Google Vertex AI Studio, you will find the option called free form. Okay, just click on that. It will help to launch the chat conversation window. Okay, so this is the dashboard which is having the lots of settings and parameters you can customize at your convenience. Okay, so first we will change the large language model Gemini variant to enable the stop sequence. Actually, in this variant, we are unable to see the stop sequence parameter. So by just doing drop down, you will find a lot of Google Gemini variants. So you can choose any one of the variant which is applicable stop sequences. Okay, so in this model, you can apply the stop sequences. So here I am just asking I am providing the small prompt without any stop sequences. Here actually you can mention the stop sequences to control the large language model outputs. Okay, so I'm just asking, hey Gemini, list the key features of Gemini 1.5 Pro. Okay, so I'm just clicking on the sending button. I am not providing any stop sequence. This is practices without stop sequence parameter. Okay, see this. So this is just doing content generation. Okay, so it has stopped the process. Okay, So now we'll do some practice with by mentioning the stop sequence. Stop sequence are not any specific. You can use symbol, you can use a word, or you can use any unique uh, parameters or texts like this. Okay, you can use the hashes also as a stop sequence. So here for our practice, first time I am using a common word, that is the. You can use the dot EAM or also as a stop sequence to control the large language models. So again, I am just asking the same question with the same prompt. I'm not changing anything here, but the stop sequence is the. Okay. Let's see how it reacts, how it produces the content. See this. For example, if you compare with the earlier response by the Google Gemini, so in this response, it's automatically suddenly stopped text generation process when the large language model internally finds the stop word, that is the. So the main point is here, when large language model internally finds by generating the text, automatically stops when it encounters the stop sequence word, that stop sequence symbol, that stop sequence string, anything. So this is how stop sequence controls and suddenly stop producing the content without further actions. That is the power of stop sequence. Okay, now we'll dive into the how this stop sequence works internally in the large language models. So when it comes to the large language models, the stop sequence acts as a trigger to cut off the text generation process. The large language model generates one token at a time. That means one token means here consider as a word that predicts the next token based on the prior content, prior context, what it has produced. In simple terms, large language models are like GPT or Google Gemini or Bloom or any large language model generate the text token by token. That means every time when at each step, the model checks if the sequence of token or word generated matches the stop sequence provided by the user. So what I have provided here, I have provided the stop sequence as a the. So as I said, in each step, the model checks if the sequence of tokens or words that are generated by the large language model, when the stop sequence matched or encountered by the LLM that are provided by the user, suddenly it stops generating the process. That means LLM every time predicts the next token using the using the probabilities based on the input prompt provided by the user and the tokens that are generated so far. That's how large language models internally keep identifying the stop sequences, and when it finds, it will automatically stop generating the text. So if the stop sequence is detected, the model immediately stops generating the further content, even if the response is incomplete, like this. So see this, it's not going further. It stops at depending on. This is how stop sequence controls the large language models output. Okay. So when it comes to the example, we'll break down this. If the model doesn't see actually the large language models are not predict the entire context, the input provided by the user. So it's actually generating one single word. one token by token, as I told, token by token. So if one token is generated, that means one word is generated, it predicts the next token immediately. In the process of predicting the next process, in the next token generation process, if that find the word the, as we mentioned, the stop sequence has the, immediately it stops. Simple. That's the reason here, if yes, if yes means if the large language model finds the token that is as a word, that is the, it immediately stops the text generation process. If it is not found, it will continue the text generation process like this. So in the first, for example, if I ask the word, hey, what are the benefits of exercise? Okay, we'll just ask this. What are the benefits of exercise? So now here I am changing the stop sequence as one unique stop sequence. I am just using stop sequence in unique. Let us see how much content it is going to generate. See this. It's simply generating the text until it finds the stop sequence or it reaches the timeout process. See. So it generates the text until when it finds the stop sequence. Okay. So I'm just copying this text. Actually, I'm going to compare with the next one. The same prompt. I will just ask the same prompt without stop sequence. Let us see the how many tokens it is generated. Total. Actually, you can find the tokens also. How many tokens are utilized here? Unfortunately, not here. Okay, so I'm just removing this stop sequence. So now without stop sequence, we'll see the response, how much content it will generate. Actually, around it will generated this much of content. Okay, let us see how much content it will generate without stop sequence in the same prompt. Just keep on generating. It is still generating. See this. So this much of content is generated by the large language model in this variant. This is the variant we are using, Google Gemini 1.5 Pro 002. Okay. So this is how large language models are controlled by the stop sequences. Now I'm just using another common parameter, that is a regular word, that is. Okay. I'm just using is as a stop sequence. Let us see how it produce the content with the same prompt. Okay. See this. It stops generating content where it internally finds is the next word like this. So it's keep on generating the token by token. When it's find internally the word is, just assume this is a is, automatically it stops generating the content. This is how stop sequence works behind. Okay. So the key takeaways are the stop sequence are rigged the large language model rules. If the model encounters output the exactly is a symbol or phrase or a token, it will immediately stops text generation process regardless of the length of response, whether the answer is complete or incomplete, and the produced content meaning or relevance of the topic. So it doesn't care about your response or output or your ask. It is simply stop when it encounters the stop sequence which is provided by the user. This is how it works in behind. Okay. So, okay, I got a doubt actually based on my research and studies. I have gathered a few real time questions and asked the chat GPT. It produces some content. So in case, for example, I have provided the stop sequence as is or the or whatever it is. In that case, what happened if the stop sequence never found in naturally when it's content generation process? What happened? So when the large language model didn't find or didn't find the stop sequence naturally, what will happen? So if the large language model doesn't naturally predict the stop sequence in the flow of its output text generation process, the system will have to step in and stop generation process manually after certain point of time. What are the points? This is usually happen when the model reaches a certain limit, such as maximum token limits. Most of the LLMs have limit on how many tokens they can work, and maximum number of tokens limit you can set it as well. For example, we'll do some practice on we'll set the token limit and with stop sequences. Okay. So here we can set up a token maximum token limits. Actually, I am just setting up 100. Okay. So maximum is 100 is the, actually not 100, we can produce 50 tokens. Okay. We can give the 50 tokens, and stop sequence is unique. Unique means it's really hard to find the stop sequence in the content production process. Okay. This is the stop sequence I have mentioned here. I think this is a unique one. It's really hard to find from its internal token generation process. So we are asking the same prompt. Okay. So now two settings I have done. One is I have limited the tokens up to 50 max you can generate, and the stop sequence is end. Okay. Now hit the button, send button. See this. Actually here, as per my analysis, here it stops when it reaches the tokens limit is 50. How do you know? How do we know these tokens are up to 50? Actually, we have a chat GPT tokenizer dashboard. We can find how many tokens it is generated. Okay. Let's find the how many tokens it's generated totally. See this. It's generated 73 in terms of OpenAI's chat GPT, but maybe in terms of Google Gemini, it is a maximum of 50 tokens. Tokens are not just a words, sometimes a phrases, single character, or words also. Okay. Don't think tokens are single word. Sometimes it may be a series. For example, strengthens. These are two tokens. This is this single word split into two tokens. This is one token and this is the another token. This is how large language models split your input into tokens. Okay. Again, back to this. So when you provided a stop sequence, but unfortunately large language model didn't encounter that stop sequence what you have mentioned, automatically it stops generating the process when it reaches the tokens limit, or maybe a timeout concept. In sometimes you will also when you are doing some practices with the chat GPT, it encounters some errors like some issues like hey, it reaches limit, or like a timeout or something. Okay. I hope you guys are already facing that type of issues are like experiences. Okay. So for example, we'll remove this stop sequence and check the response. Okay. Again, I am hitting the button. So it stops the response when it reaches the tokens limit, that is 50. But now I am going to give a stop sequence as any one of the common word. Any one of the common word is and. Okay. Actually, these common words you would not use in as a stop sequence. We should always use unique parameters. Okay. So I'm just using this as a parameter. Now we'll see how it's respond with the same prompt. But now this time I'm increasing the tokens limit. Why? Because we are practicing on the stop sequence. So I'm just increasing the tokens limit from 50 to 250. Okay. I just increased the token value 250 and I have mentioned the stop sequence as and. Now hit on the send button. See this. Hey, it's immediately stopped the response. That means it after the token, the word of physical, that immediately finds the stop sequence, that is and. That's why it is stopped. So in the previous experience, in the previous practice, the large language model produce up to 50 tokens. Why? Because the unique stop sequence it doesn't find at the time of at the time of text generation process. Now we will give the another unique stop sequence that is end. Okay, this is also you can use anytime. I'm just using the stop sequence as end, and now I'm just using and the tokens are limited up to 250. We'll see the response. I'm hitting the send button again to check the response. See, this is continuously generating the text, maybe until it reaches the token limit or when it finds the stop sequence word. If it is doesn't found the stop sequence word, it continuously generating the text until it reaches any of these limits, like a maximum token limit or maybe a timeout. It stops the response. This is how large language model works when you are using the unique stop sequences. Okay. So when it comes to how large language models or works behind means, the stop sequence is not predicted or placed automatically by the large language models. The stop sequences are defined by the user, where to stop the text generation process and ends the process, ends the text generation process. And also that LLM doesn't understand or judge whether the response is meaningful or incomplete or completed. It stops purely based on the stop sequence rules actually. Okay. So this is how stop sequence works internally, and we are already seen many different versions of the stop sequences. Okay. So these are the few common stop sequences which are recommended and which are few are not recommended. So when you use the stop sequence as a common words, as we already practiced the and is, these stop sequences are immediately stop the responses. So that means there is no use. When you are choosing the stop sequence as these common words, like symbols or words that can appear naturally in text to ensure the model doesn't terminate prematurely. Okay. So in that, using this symbols are using these common symbols or words, LLM to halt mid-generation when these tokens are encountered in output without completing the sentences. That is the reason we should always use the unique stop sequences like this. You can use any stop sequences. You can put this greater than and less than in between the stop, or you can mention any kind of stop sequences that are unique, not like a common word, common symbol, or a one numbers, anything of this. Okay. So in the next concept, we are diving into the best practices for the prompt engineering. So when it comes to the prompt engineering, stop sequence plays a vital role in optimizing the prompt engineering tasks by providing a greater control over the output of the large language models. So there are various types of controls and methods when you are doing practice with the prompt engineering. One is controlling the output length, which we already seen earlier in these sessions. Okay, so when you are using the stop sequence, it helps to limit the length of generating output, ensuring it is a concise and focused on the intended responses. Okay, so without stop sequence, the model may generate lengthy responses, often irrelevant and verbose. That's the reason stop sequence responses are cut off when the model reaches stop sequence words. Okay, and it helps to creating templates for specific tasks like a summarizing or FAQs or headline generation and all. Okay, we'll just have a one sample with the another prompt. Summarize the advantages of AI. Okay, so we are using the stop sequence without, actually first we'll try with the without stop sequence. Okay, we'll see how it is controls the text generation process. See this. This is keep on generating the text. So you already know when it didn't find any stop sequence, it will complete the task. Okay, by reaching the token limit or timeout. So when we are using the stop sequence, like we are using the unique stop sequence, that is stop. This is also you can use. Stop is also one of the stop sequence, you can use it. Okay. So now I am just hitting enter with the by typing up the stop sequence. Let us see where it stops generating the content. So it stops the generating text content here. Okay. Okay. So this is how a stop sequence controlled the outputs by the large language models. In the next concept, in the next word, so when you are using the structured outputs, so stop sequence are allow for structured and segmented outputs, which are essential in applications where specific formats are required. That stop sequence helps generated structured data efficiently, which is critical for the domain specific applications. Domain specific application means like a custom domain, custom LLMs like healthcare, finance, marketing, insurance, these type of applications. Okay. So it helps to reduce the token utilization. The key advantage I have noticed, which is you can save the token utilization with the LLMs. Okay. So here I am asking list the advantages of avoiding plastic. Okay, plastic. Here I am giving instructions separated by emojis. Okay. Just give the list of asking, and here I am using the stop sequence as dot, no dot, end. Okay, let us see how it's going to respond. So it's continuously generating as I requested. So it's producing the advantages of avoiding the plastic utilization by at the end of having the any emojis with the benefits, or it's symbolically it's showing something, okay, which is useful. Okay, so I'm using the same prompt with the common stop sequence, with the unique stop sequence. It is generated only this much. Let us see how many points we can gather with a unique stop sequence. This is the unique stop sequence I have provided to the large language model. Okay, and I am increasing the limit also from 250 to 1000. Okay, let us see the response. See this. Actually, earlier it is generated only 8 points, I guess, as I remember. It's additionally generated 3 more points. Why? Because here we have provided a unique stop sequence. I think it's internally, it finds the large language model internally finds the stop sequence as we have mentioned. Okay, that's the reason this stops here. Okay, this is how you can do more practice in your prompt engineering. And avoid redundancy. So by predefining the stop sequences, you can stop repetitive or redundant token generation, and it helps to reduce the utilization of tokens while you are doing the practices. Why? Because when you are get the large language model access, it has a limited tokens utilization or free credits. So to maximize your prompt engineering skills when you are doing or fine tuning your custom large language models, this is where you can control and minimize the token utilization by the large language models. Okay, that is the reason we are using the large language models are introduced these type of parameters like a temperature, top P, top K, stop sequence, and others. Okay, and also the token efficiency in iterative refinement. In iterative refinement means stop sequence save tokens by limiting access the output. This efficiency is especially important for prompt engineers working on fine tuning the prompts or processing multiple responses. When you are doing iteration with the prompts, keep on trying with the new prompt or by updating the prompts to get the desired output. Automatically you are utilizing the tokens. So when you are using the stop sequences, it controls the utilization of the tokens. That's the reason we always recommend use the large language parameters, whatever it is, based on your client's requirement and tasks requirement. Okay, and coming to this domain specific, This is also very important. In domain-specific large language model applications, when you are doing practices, the stop sequence ensures that output stay relevant and aligned with the domains languages. Domains means here like a finance, marketing, insurance, healthcare, or legal law industry as well. When training or fine-tuning their domain-specific large language models, excessive token generation wastes computational resources. Computational resources means it's like a GPU utilization or TPU or CPU utilization also increase high. To control that also, stop sequences are helping. Okay, so stop sequence limits the response to specify the length or sections, reduce the training noise and token wastage. And also, stop sequence helps generating structured data efficiently like this. So it helps to produce the structured data efficiently, which is critical for customized LLM applications. Okay. So this is how you can do practice in your prompt engineering practices. Okay. So here, finally, I have done some research with the ChatGPT. It produces some unique and some special type of stop sequences that are like a hash n. When you are using the some different types of applications. For example, if you are using the new line, to stop the generation after a single line of response, you can use this symbol. Okay, now we'll try with this stop sequence parameter. Okay, so I'm just mentioning here n. That means when it's trying to enter the next line, automatically it stops generating. Okay, now I'm just removing this. So avoiding plastic. Okay, we'll see the response. How it is keep on generating. It's not found the, I think it's not found the stop sequence which we have mentioned. Let's try the another one. User. Actually, this user, ideally, we are using this type of stop sequence parameters in chatbots conversation. When it has a conversation with the user, when it has a conversation between user and chatbots, so immediately when a user asks some question, immediately chatbot provides some output as a answer, and it stops producing the content, ask for the next question, and it's waiting for the term. So this is how you can use this parameter when you are developing or designing or training the chatbots. Okay, and this is also one of the unique stop sequence you can use. We already tried earlier. Okay, these customized tokens are these custom tokens are especially useful in structured model outputs like APIs, or when you are working with the custom specific large language models. And okay, and the stop also we already tried with this full stop. When you mention this full stop, automatically it stops generating the content immediately. It's not providing any further content. And also we try with these 3 dashes how it's going to work. Okay, so and to mark the end of section of these pages, especially in document or multi-paragraph outputs, you can use this 3 dashes parameter. This documentation or summarization tasks. That's how it works. Let's try with this 3 dash. Actually, I think it's having one space, maybe. I'm removing the space. Okay, 3 dashes. So now I'm asking the same prompt, sending the same prompt. Let's see how it's going to respond. I think it's internally the LLM doesn't find the stop sequence. That's the reason it's keep on generating the text. As we already know, when the large language model didn't encounter the stop sequence which is provided by the user, it's keep on producing the content until it reaches the tokens limit or maybe timeout of the text generation process. Keep in your mind, okay? So this is how stop sequence can control the large language model's text generation process. Okay. So as I mentioned earlier, initially, I will show you how to get the generative AI certification free of cost. Actually, LinkedIn is offering 2 free certificates which are offered by the combination of the Microsoft and LinkedIn. So this is the certification. It's a no cost certification. You can go through this and complete the lessons and write the exam. You will get the certification. This is one certification provided by the LinkedIn and Microsoft, and this is another certification. These are free of cost. You can get it easily without cost. Okay. This is another certification. Okay. So that's a wrap of stop sequence. Now you know how to take full control of large language model output and keep it concise and make it work exactly how you need it, the response. If you found this video helpful, make sure to hit a like or subscribe to the channel. And happy prompting. Thanks you for watching. Have a good day.